Okay, you guys have already listened to the Chapter 1-5 video. Now I'm going to start some worksheet questions with you. This is number 2. Now, we're going to first pretend that the greater than or equal to sign is going to be an equal sign. So what's the first step I would do if I were pretending that was the equal sign? Well, we would need to distribute. Very good. So a plus 3 is greater than or equal to 6a minus 42. Okay, now I'm going to pretend that this thing is an equal sign, so I need to get all my a's on one side and all my numbers on the other. So I'm going to subtract a from both sides. 3 is greater than or equal to 5a minus 42. Then, pretending it's an equal sign, I'm going to add 42 to both sides. And I get 45 is greater than or equal to 5a. And now I need to get rid of the 5. So how do I do that? It's attached by multiplication, so I divide both sides by 5. I get 9 is what? Do I flip the sign? No, I do not. I keep it because I did not divide by a negative. Now, many of us are very used to having the variable on the left-hand side, so let's move that over. The arrow is pointing to the a previously, so it's going to point to the a now too, to give me a is less than or equal to 9. How do I graph that? I put 9 on the number line. Is it opened or closed? It's going to be closed because it can be 9. And I'm going to shade that the direction of the arrow is pointing because the variable is on the left, so I'm going to shade to the left. And there is your answer. Number 3, pretending that inequality symbol is an equal sign. What is ugly about this thing? Go ahead and put that all over there. And what's ugly about it is the 2, so I'm going to multiply both sides by 2. So that cancels that out, and I'm left with 1 times 8 minus 3g. Did I multiply by a negative? No, I did not. So therefore, the sign stayed, and that's going to give me a 4. Now, does the 1 change anything when you multiply? No, it doesn't, so I can drop the parentheses. Now I'm going to get rid of the 8. It's an adding, it's a positive 8, so we can subtract the 8 from both sides. Negative 3g is greater than or equal to. I do not flip the sign because I'm subtracting. I didn't multiply or divide. So that's going to give me negative 4. Now divide by negative 3. And I have g. Did I divide by negative? I did, so now I flip the sign and I get positive 4/3. Go ahead and put 4/3 on the number line. Is it opened or closed? Well, it's going to be closed because I have the less than or equal to symbol. And therefore, since my variable is on the left-hand side, I can shade the direction of the arrow. And I shade down to the left. Number 6. Number 6 is a compound inequality. Why is it compound? Because it's trapped. My letter B is trapped in between the 2 inequality symbols. So how do I work this problem? I'm simply going to act like I have 2 problems here. So with that said, I'm going to show you exactly what I mean here. Since B is in the middle, I'm going to pretend that I have 2 problems. So what would I do if I had this problem? Covering up the left-hand side, so I have that 1/3. If I extend that fraction, I see that what's ugly about that is the 3. So how would I get rid of that 3? It's attached by division, the opposite of multiplication. So I'd multiply both sides by 3. So now let's go to the other side. If I cover up that side, what is it's the same issue? It absolutely is. So therefore, I'm going to multiply the entire equation by the value 3, just like we did whenever we got rid of our fractions. So that's going to give me negative 12 is less than or equal to 1 parentheses b minus 7 less than or equal to 3. Now I have no fraction. Do I need the parentheses here? When I multiply something by 1, it doesn't change it, so therefore I can drop the parentheses. Now I ask you, if I had this problem, what would I do? To get rid of the 7, it's attached to the b by subtraction. So what is the opposite? You said addition, you're correct. So I'm going to add 7 to both sides. But this time I'm going to add it to the left, to the middle, and to the right. And this is going to give me negative 5 is less than or equal to b, which is less than or equal to 10. Now how do I graph something like this? I'm going to put my 2 numbers on my number line. And is it allowed to be 5? And is it allowed to be 10? The answers to that is both yes. Why? Because I have less than or equal to symbols. So they're both allowed to be negative 5 and 10. And where is V? Well, V is trapped between those two walls, meaning it's trapped between the numbers negative 5 and 10. So those are the only possible answers that you can get. Number 9, this is an and. What does and mean? And means to overlap. Okay? So what we're looking here is we're going to solve these two equations. And we're going to put them on the same number line. What you're going to see is they're going to overlap. So we're going to have 3x divided by 3 and negative 6 divided by 3. Did I divide by a negative? No, I did not. So I keep the greater than symbol. That gives me x is greater than negative 2. I come over here, and I need to get rid of that 2, so I'm going to divide by 2. And I get x is less than 3. Okay, so now, if I put these both on a number line, here's negative 2. It cannot be it, so I'm going to have an open dot. And I'm going to shade to the right because my variable's on the left. Now I'm going to put 3 here, and it cannot be 3. And it says I'm going to shade to the left this time instead of the right. Now, where do they overlap? Well, the place that they overlap is in the middle. So what this means is you simply, if I can get my page fixed, put negative 2 on the line and 3 on the line, and it's opened at 2 and it's opened at 3, and the shading is in the middle. That is an and statement. So how do I show this as my answer? Negative 2 and 3, and x is in the middle. Now, what's the relationship between negative 2 and 3? Negative 2 will always be what compared to 3? Will always be smaller, so you're going to use the less than symbols, and then you're going to check to see if it is an open dot or a closed dot. Now, both of these have open dots, so therefore you're going to use the strictly less than symbol. So these two that I've boxed in down here at the bottom are your answers, the ones I've highlighted here. The top ones are not your answers. That's what actually are that's your work. But the two highlighted answers are going to be your absolute answers at the bottom. Now this one's an or. Since this is an or does not overlap. They go in opposite directions. So if I solve this problem, I divide by 2, and I have x is greater than 3 over 2, which means I did not flip the inequality symbol because I divided by a positive 2. So I come over here and I have 2x is less than x minus 3. I'm going to subtract the x, and I have x is less than negative 3. That cancels out. And that's your problem that's done over here. Now I'm going to put these both on a number line together. Negative 3 is smaller. 3 over 2 is larger. And x is greater than 3 over 2 is an open dot. And I'm going to shade everything to the right. When this says over here x is less than negative 3, it's an open dot, and I'm going to shade everything to the left of it. So now this number line has two possible regions for answers, and I'm going to simply put them together. X is less than negative 3, or x is greater than 3 over 2. These are your answers. It's 4, so therefore that's why they go in opposite directions. Now, on the back of your worksheet, you have to write an inequality statement. From words, you have to write an expression. This expression has to have an inequality symbol. Okay, so a number increased by 7. What's increase mean? Well, that key word is going to be addition. It's increased. My pay is increased, so I want to go up. I'm adding to it by 7. And that is less than, well, there's another keyword. Less than, you can immediately tell that that's the less than symbol. It's all the numbers to the left of 0. Is less than 5. So how do I write this? A number, in this case, do I know it? Since I don't know it, that's going to be x. So I'm going to have x plus 7, because it's increased by how many units? By 7. It is less than. Well, the less than symbol goes here. Can it be 5? It didn't say it could be 5, it just said that it's less than. So I have to strictly less than 5. Okay, and the next part is you actually are given the answer in graph form, and you have to come up with the lovely little equation part. So what I want you to notice is this is an and or an or. This is an and statement, and the reason why is because x is trapped. So since x is trapped, what you're going to do is simply put -8 and then the 5, and x is trapped in the middle. Since x is trapped in the middle, you need to always use the less than symbol when x is in the middle. Okay? Now, since -8 is always less than 5, now you have to ask yourself, is it opened or closed? Well, it's closed, so therefore I have to add the less than or equal to symbol on the -8. And is it opened or closed at 5? It's open, so open means less than, and then closed means less than or equal to. So this is going to be your inequality statement. The next one is strictly going to be only one. X is not trapped because the arrow goes on forever, so x is going to be strictly greater than -12. Okay? Any questions over this? We'll go over it on Friday, and the rest of the time is yours to complete your worksheet. It needs to be done tomorrow, though. At least attempted everything.